Hi, it's Elizabeth, and this is Engineering Economics video number 15. And we will be learning about net present value, also known as NPV. It's also called net present worth, NPW. It all means the same thing. Okay, but first a little bit of review. What do these letters right here stand for? EUAB and EUAC. What do they stand for? And if we divide those two figures, if we divide benefits divided by cost, just gave you the answer. What is that relationship of the ratio? What is that relationship to 1? The number 1. What do we want that relationship to be? That ratio should be greater than 1, right? In order to have that investment be financially beneficial. Okay, so then we want to turn all cash flows into their equivalent annuities. I bet you got it. Okay, and I realized we didn't go back to, I never really finished the last video, EUAB and EUAC ratio that we want to be greater than 1. So I'm just going to flip back to the previous video example for just a minute. And if you recall, we ended up in this example with an equal uniform annual cost from this investment of annual cost of $27,050. But I didn't do the ratio part, so let's do that now. So equal uniform annual benefit in their example was $350 benefit. And that, if you remember, was the salvage value out in the future. And we had some costs. That's the only benefit we had. And we had some costs of $9,400. And that came from our initial cost, annualized. And then we had $18,000. And that was the annual operating costs per year. So that already is in terms of A. So those are the benefits divided by the cost. That I didn't even do the math, but that is obviously far below 1, so less than 1. So do not accept that project. That makes sense with our EUAC. Equal uniform annual cost was a big number, an annualized big number average cost to running that machine. There weren't very many inflows from that. So just finishing off that ratio from our previous example on the last video. All right, let's go on to today's topic is net present value. And the idea here is, this is an important concept, NPV or NPW, is the present value of inflows minus or less the present value of costs. So we're taking everything to their present values. So here we have, so basically it's find P, right? Find present value of all the cash flows and then sum them. And we want it to be greater than $0. Okay, but we'll get to that in a second. So here's a cash flow diagram. The initial cost is an outflow that's already in terms of present value. And then what we want to do is take all these cash flows and bring them back to their present value equivalent, no matter when they happen. If two cash flows happen at the same time, remember you can net them before you even do the discounting back to present day dollars. So basically calculate present value for each cash flow, sum them, and the decision rule is we want our net present value or net present worth to be greater than or equal to 0. So net present value tool takes the time value of money into account, right? We're using this discounting method of bringing everything back to its equivalent present day dollars. So we can compare the inflows and the outflows, everything's on a present value basis, the same basis. So here's an example, same numbers that we used in our last video. A machine initial cost is $80,000, annual operating cost of $18,000, estimated future resale value of that machine is $20,000, 10% interest rate, 20-year life. And instead of finding the equal uniform annual costs and benefits, now we're going to find the present cash flow. I'm sorry, the net present value of that cash flow. So I've drawn a timeline here of the cash flows just to get a little picture of it. Remember that 18,000 is an A, the 20,000 is a future value, and the 80,000 is a present value. We want to find the equivalent present value for all of these cash flows. All right, so I've done that here down on the bottom. 3 columns, the cash flow, so just a description, and the dollar amount, the equivalence calculations, and then the result, which we will then sum to come up with our net present value or net present worth. So initial cost is already $80,000. I've put brackets around it to show that it's a negative or a cash outflow. You could put a minus sign in front of it as well. The operating costs are $18,000. Average, right, or that's the annuity amount. So we want to find P given that that annuity amount, that was annual operating costs. So find P of that cash flow stream. Interest rate 10% for 20 years. So we take 18,000 and multiply it by this factor from the interest tables. And again, we get a negative present value of that annuity stream in today's dollars is negative 153,245. So that would be bringing all these annuity $18,000 cash outflows all back to today's value and add them up. Their present value is 153,245. Then we have the salvage value of $20,000. We want to find P given F, 10% 20 years. So there's its interest table factor. Multiply that by the $20,000 future cash flow, and we come up with a positive cash inflow of $2,972. Okay, then we sum all these up and we get to 230,273 negative, right? Because these big negative numbers. So that's the net present value or net present worth. We want it to be greater than 0. This one is less than 0. So the answer is do not invest in that project unless there's some other qualitative reason to do so. It is not financially beneficial the way these cash flow estimates stand. So net present value is a negative number, do not invest. That's the same result we came up with the same set of cash flows with our benefit cost ratio, right? Do not accept. Benefit cost ratio equal uniform annual benefits and costs. That ratio was less than 0, or I'm sorry, less than 1. The ratio is less than 1, so do not invest. So we came up with the same conclusion using 2 different analysis methods. Both of them use the time value of money, right? Okay. Here's some general criterion for figuring net present worth of a potential investment or project. These are important steps. You should have these in your notes. So just quickly, step by step. 1, determine the appropriate rate of return that the company wishes to earn on this potential investment. Appropriate rate of return is I. It might also be called the discount rate, the minimum acceptable rate of return, MARR, or required rate of return. It all means the same thing and it's designated by the letter I. Step 2, estimate the useful life in years or months of the project. Step 3, estimate the cash inflows for each period. Maybe those are each year, or maybe they are monthly or quarterly, but estimate the cash inflows, estimate the cash outflows, and determine the net cash flows for each period. That's just the inflows minus the outflows, and a diagram, a cash flow diagram is useful in this step. So you can see a picture and you can net cash flows that happen at the same year. Easily see that from the diagram. Okay, step 6, find the present worth or present value of each net cash flow at the selected interest rate determined in step 1. Find the present cash flows and add them up. I didn't write that, that's step 6A, right? Sum them. Then step 7 is decide. If present worth or present value is greater than 1, accept the investment. If present worth is or present value is equal to 0, you're indifferent, must use other criteria to decide, non-financial. And if present value or present worth is less than 1, then you reject the investment on a financial basis. There might be other reasons to still do the investment from a qualitative basis. There might be other factors, but from a financial standpoint, if present worth is less than 1, don't do it. Important concept, just real quickly, if we're ranking several investment alternatives, select that one with the highest NPV first, as long as the service or useful lives are the same or very similar. And if there's unequal service lives in your alternative investments, then we do make some special assumptions in another video. But let's get to an example here of finding net present worth. New numbers now. Initial cost is 1.8 million. Projected cash flows, year 1 is 454,000. Year 2 is 681,000. Years 3, 4, 5, and 6 are 908,000 each year. In year 7, we have projected cash inflow of 1,268,000. The interest rate is 15%. Find net present value, also known as net present worth. Value or worth, same thing. All right, so here's our, I could draw a cash flow diagram, but here's what you'll end up calculating. Year 0, the initial cost is 1.8 million negative, right? Because that's a cash outflow. Put that at the first. It's already in terms of P. We want to turn all these other cash flows into their present value equivalent, right? So we can compare them. Year 1, 454,000 times a factor from the find P given F column, 15% interest table for year 1. There's that factor, so we multiply the factor by the dollar amount and get a positive cash inflow in present value terms, 394,798. Same for year 2, 681,000, only now we're working on row 2 because it's the second year. There's that factor, multiply it by the factor by the dollar amount and get the present value of that future cash flow. Now years 3 through 6, we have an annuity, right? This is an annuity. So we can take a little shortcut, but it's 2 steps. 908,000 is the amount of the annuity. So we want to find P given A at 15%. Now why the 4 here? 4 because it happens 4 times, year 3, 4, 5, and 6. So we use a 4 there. There's that factor, multiply it by the dollar amount, 908,000. Then we need to slide that cash flow back earlier. So we need to slide it back in time 2 years. So we multiply that result by another factor, find P now given F, the one sum future value that we calculated here. We want to find the present value of that. So find P given F, 15%, slide it back in time 2 years. Remember the trick from the other video, the 4 plus the 2 equals 6, and that is the ending year of our annuity stream. All right, go back and watch that video of how to slide numbers, annuities back in time, if you forgot that. So we multiply 908,000 cash flow by the 2 factors, and we come up with 1.9 million. Year 7, we have a single cash flow out in the future, so find P given F, 15%, and that happens in year 7. So there's that factor there, multiply, and we get a positive present value of that future cash stream. So what we want to do now is sum them, right? So we add up this entire column of numbers, and we get approximately 1.5 million. You might get a little different here at the end, depending on how many factors your interest tables go out to, but it's around $1.5 million. That's net present worth, also known as net present value, and that is greater than $0, so we accept the project. All right, so a couple things I want to point out here, and that is just the cash inflows right here, just what I'm highlighting. Let's change color. If we were to make this blue, you could see it a little better. Just the cash inflows in their present value equivalents, just those added together, is called the present worth or present value of the future cash inflows, right? And we want that to be greater than the present worth of the cost of the asset and any other cash outflows. So again, what we've done up here is just net them. So you could do the same thing. You could take the inflows minus the outflows, all on a present value basis, and you'd come up with the 1.5 million. But there's another thing. If we take those 2 numbers and divide them, like here, we get a number, 1.86. It's a ratio, and that is known as the profitability index. And it's also known as the cost ratio in present value terms, right? Present value or present worth of the inflows divided by present value or present worth of the outflows, benefits divided by cost on a present value basis, also known as profitability index, and we want that to be greater than 1. This is, so it also says except the project. So benefit cost ratio, profitability index, conclusion will be the same as the net present value decision, because they're using the same numbers. Just divide them or sum them, right? You should come up with the same answer. All right, that is it for present value. Thanks.